Howdy. It seems that we have to talk quickly about mountain water. This is the paper, my recent one, which got published. I will put links below, you can have a read. It is about many different things. Mountains and such. Because there they say it by themselves. Textbooks and geoscientists may be wrong about how the Alps were formed. Yes, this sparked a very big interest in me. And since I grew up in Switzerland and have been in the Alps many times, it was very interesting to make research about this. So the thing is, we have to scroll down. Here are hot springs and stuff, the River Rhine, and geothermal potential of Europe. Joule antennas and geometry, micronovax, explanations, or how to put it, where glacier starts to grow, or start to grow. According to Britannica 41, we just recently, I showed one article from Britannica, I think it was about Halloween. Glaciers are perennial accumulations of ice, snow, and rock. Common theory takes only accumulation through precipitation into account. Precipitation plays a role in the process, but we have also to take into consideration that many glaciers could be fed by groundwater. This is a very important new perspective. The source and the route of the glacier depends on the geographical location of the spring, elevation above sea level, and latitude. Whether there is a glacier growing or not. If the spring is in a permafrost area, the possibility of glacier forming is suitable. We know that climate changes. It did so in the past, and it will do so in the future cycles too. The water feeding the glacier is slightly warmer, not frozen, than its surroundings, otherwise it wouldn't flow, pushing the glacier downhill. Which means that the influence of gravity is smaller than previously thought. Glaciers are rather short-lived lava streams made of water. Mountains are peppered with springs. Some are just normal springs, some are rich in minerals, and some are hot, and some are almost on mountain peaks, and some are even radioactive. You can make a whole read through. Maybe we just glaciers can be divided. I'm here somewhere. Glaciers can be divided into three groups. Glaciers which extend into all directions and form sheets, for example, Antarctica. Mountain glaciers which have a certain path due to the surrounding terrain, valleys, and glaciers which spread out on leveled ground. They are called Piedmont glaciers. There are much more than just a part of They are much more just a part of a bigger glacier, so not really a form of a glacial activity itself. The Piedmont glaciers are those which are going on the water. The question must be asked, if alpine glaciers flow because they are on sloped surfaces, because gravity pulls them down, how can ice sheet glaciers expand in all directions simultaneously? It must be asked, when talking about Piedmont glaciers, which can extend far on the surface of the water. If glaciers, according to common theory, carved out all the valleys, where are the piles of gravel and rock? We should expect piles of debris which are as big as the mountains where they got carved out from. The only form of debris found are the moraines, which are rather small compared to the rest of the landscape. Some of the moraines even show layering of different sediments. Why do we often find lakes where the glaciers has once begun? How such geological formation, like a lake, which has craterous features, i.e. an indentation in the ground, could have been formed in the first place? The water in lakes is thought to be accumulated by precipitation and melting, but a connection to groundwater should be taken into account too, since many of these lakes never dry up. Frequently, also mudslides and flash floods are in the news. Usually, the official explanation is heavy rainfall in the mountains. I think generally that seems to be correct, although in some instances there might be mudslides or flash floods that don't really need rainfall to occur. In the proximity of volcanoes, they are called lahars. But we don't have any listed volcano within the Alps, and no one ever considered alpine lahars. I do. Lahars are usually linked to volcanic activity. They are part of fast melting processes and water runoff during seismic unrest or volcanic eruptions. They can happen before, during, and after increased activity. Is it possible that something very important got overlooked? It might be also very well possible that the water which is coming downhill into the valley has its origin, at least partially, underground. Groundwater gets pushed up to the surface quite much like a glacier. The forming of glaciers needs two things: water and cold temperatures. A slope or a downhill landscape is not required to form a glacier. A mountain lake which is continuously fed from below will push water upwards even when the lake freezes. If this process continues for a prolonged time, the lake will overflow and it will form a stream of ice, i.e., a glacier starts to form. Yeah, but I won't now just make a whole read through to that because it would take a long time. So it's probably easier for you if you're interested into that, because obviously it just continues. Read it. I will put a link below. You can download it and read it. There are a few other very interesting articles in this same edition of the journal. But now we continue just a little bit, because I am coming possibly to the point why I made this video in the first place. One really interesting feature of the Alps are the wide rivers. These kinds of wide rivers, as I call them, aren't only present in the Alps. They can be found all over the world. I have made many videos about wide rivers and stuff. Hundreds. The following picture, figure 16, is made with basic Google Earth.com footage, free of filters or enhancements. Because I cannot really do them, I'm not an IT person. Mont and Helens, USA. Do you see anything which looks like a white river? I do. Mont, France. White river. Udine, Italy. Parma, Italy. Valgau, Germany. There is even this very nice 90-degree bend in this one. Nalchik, Russia. You can find them almost wherever you go. White rivers. Figure 16 shows several wide rivers from different mountain ranges and different continents. Interesting that we have one very prominent volcano, Mount St. Helens. In the USA, it fits very well in the picture and has undeniable wide rivers. So now we have to go still on a little bit. Yeah, this is what I think is in the center of Earth. There might be a plasmoid. That's the reason why we have atmospheric layers, or an atmosphere in the first place. But anyway, brick floods, 1993. I want to bring forth the example of the brick floods in Switzerland, which happened in the year 1993. Same year as the Mississippi River flooded in North America. Large parts of the city were destroyed. The official explanation is that heavy rain triggered the floods, Rain was for sure part of the whole event, but the amount of water that flooded the valley was staggering. Yeah, I saw it in the news. I have been there a few weeks later. There was still a huge mess. It surprised everybody. Not only the amount itself, but also the very quick rise. Or, yeah, to rise it. As visible in figure 20, the water rose so quickly that people couldn't bring their cars into safety. Yeah, there was a lot of water. You can find videos about that. Brig is situated in one of those main valleys in the Alps, not too far away from the Alps' biggest glacier, the Aletsch Glacier. In the valley itself flows the Rhone River, which discharges into the Mediterranean Sea. Brig also has geothermal activity, which is used for a thermal bath. A new geothermal energy plant is planned there too. Furthermore, is there also a mineral water spring in relatively close proximity to the city, around 10 kilometers, but 1,800 meters higher is Lake Portel. A small lake with a crater or caldera-like form. From close inspection of satellite images, it is obvious the edges of the lake contain different layers of sediment. Some seem to be piled up in a manner like you would expect when there is high water and fine-grained sediment involved. It is very well possible this lake had an eruption in recent times, at least once. This lake is the stream Saltina's source. The Saltina was blamed for the floods. The name Saltina comes from the Latin word saltare, to jump, and has records of flooding as early as the 14th century. We have to assume the stream's name is no coincidence and can be seen as a warning from the ancient people. Yeah, if you want to consider 14th century people as ancient. Like earlier mentioned, many hints were there in plain sight all the time. Many just have been overlooked or they aren't taken serious anymore because for a long time nothing happened. The knowledge died out. A huge amount of water poured out of it in a very short amount of time. The water was quite likely perfectly drinkable in quality. This possibility should be taken into consideration. This assumption is based on the absence of news about the water being poisonous. Because many of these types of mountains which spill out drinkable water and carry glaciers are actual volcanoes, it makes sense that no one expected them being actual volcanoes. The floods in Brig were perhaps a non-poisonous cold lahar. Remember, cold lahar, a flash flood which is related to volcanic activity. Bad weather, heavy rain, and lightning were documented at the time of the event, indicating a huge electromagnetic potential was provided from the atmosphere. As much as the water which drops from the sky has different speeds according to the strength of the discharge, lightning may also reach upwards from the ground towards the heavens. Possibly a weather system with enough electromagnetic potential could trigger an eruption from a sleeping cold water geyser, i.e. a cryptogeyser. The following images, 21, 22, 23, illustrate my explanation. The lake from above, and you can see the drainage path. It went down to the city straight. And the surroundings as it looks like a crater. The Bortelsee, from up close, we can see a pattern in the ice, which makes me think this looks like it would be fed from below. It is rather circular. And here's it once again, the Bortelsee here on the right, the drainage path into Brig, and the geothermal activity, which is very close in the valley. Why I'm talking about that? All these things, white rivers and cold lahars. Because there has been something in the news today which catched my attention. Mount St. Helens volcano. Yeah, we just talked about Mount St. Helens. Elevated seismic activity poses no threats so far. Current status normal or dormant. The Cascades Volcano Observatory reported that seismic activity at the volcano has been elevated over the past 3 months. More than 400 earthquakes have been recorded by the local seismic network since July 15th. During late August to early September, approximately 40 to 50 small quakes occurred per week. Despite the increased seismic activity, the volcano remains at background levels according to the Volcano Observatory. No significant changes have been observed in other monitoring parameters, and despite the increase in microseismicity, there are currently no signs of an imminent eruption. Now, St. Helens, that's from 17th May. USGS reported that at 20:45 on May 14th, debris flow in Mount St. Helens, South Coldwater Creek, destroyed a highway. Coldwater Creek. Debris flow, which could be considered, since we are at Mount St. Helens, which is a volcano. It is a cold water lahar, or it was a cold water lahar. As it says, Coldwater Creek. So there is a volcano, and there's somewhere pouring out cold water, and it can form debris flows. All news information about Mount St. Let's see if it find it here. Because there's something very interesting about Mount St. Helens. Something I read once, and it's stuck in my head. Mount St. Helens volcano hardly needs any introduction in its spectacular eruption in 1980. It placed itself deep into collective memory, in particular within the northwestern states of the USA. Prior to this eruption, and its gradual reawakening, little attention had been given to the volcanic nature, and the beautiful mountains was a popular landmark for excursions. And then it just went boom. The eruption, which growth at the end, including formation. Maybe it's not here. But it says somewhere that Mount St. Helens has the fastest growing glacier on Earth in its caldera. Yes. Mount St. Helens has a glacier on top of it. And it is a volcano. So now let's go quickly over still back to the Swiss Alps. These are the Swiss Alps or French Alps. These are the Alps. Yeah, it's still loading the quakes. But that's the area of interest. These are 7 days of quakes. We are going to Chamonix. Yeah, I just noticed something. This is where I have been talking in the paper. Brick. Now let's just try it out if we can see it. Because it's sometimes very hard to find this little lake. Maybe that's Bortelsee. Bortelsee, yes, this is the one I have been talking about in the paper. Brick is the city which got flooded. And there's a quake rather close. Goppenstein, 23 kilometers in depth. Whoa, that's interesting. And that's another deep one. 29. But anyway, we have to go here. Let's go over here. For those who know, you see it already, Mont Blanc, the White Mountain. It is the highest peak of the whole Alps region. And beside that, now let's go over to satellite, because then you can see what I mean. And beside that, we have glaciers. Mont Blanc. That's the highest peak of the Alps. So that's a rather big mountain in general. And Grand Joras, here, yesterday, 1.4, 1 kilometer in depth. That's not very much. 5 days ago, 2 kilometers in depth. 6 days ago, 9 kilometers in depth. There's another one. And this is a place where I have noticed some months ago that there is almost constantly earthquakes going on. And as you can see, there's glaciers, mer de glace, and water streams, which according to this map start somewhere up here. So maybe Chamonix, which is a rather famous town, they should be aware of possible flood events, because it's possible. There seems to be something going on beneath this mountain. And there are many glaciers. Some of them are rather big. And for those who remember, Les Diableries, where we have Glacier 3000 with this, where we had this strange fire some months ago. On this mountain, or in this glacier, there has been some pictures somewhere in Google Earth, and I saw that there is something red within the ice, and I just wondered if it could be iron. If it would be iron, the whole mountain would be a huge antenna. Iron bearing water. Which, from a geoelectric point of view, would be something very interesting. But anyway, this is just what I think. 3 very interesting places in the Alps, possibly iron carrying glacier. Here, the highest peak in the Alps with this ongoing quake swarm, which is very interesting. And then here somewhere is this brick I just talked about. No, I missed it, wasn't there. It's here. And not too far from brick we have those deeper quakes, and there's actually some more quakes here going on too. 3 days ago. Yeah, there's water veins drawn all over the place. And water bodies. Four kilometers in depth. So, just be aware of this situation in the Alps. There is something going on, I tell you. Be aware, watch the weather. And if you are living there, just keep your stuff ready in order if you have to leave quickly. Never know. Thanks.